What comes with tomorrow at night? Before we settle to sleep, we'll pose this question to ourselves. It may well be the greatest riddle facing humankind. We cannot help but ask what the future holds for us. Fretting over the unknowns that wait ahead, anyone would love to peer a few days or years forward into what's coming and glimpse how their life might unfold. Will I inhabit the life I've imagined? Or does something truly painful wait to strike? So, what's the worst fate that could befall me? Death will in the end take every one of us. Nobody in known history has ever escaped death, and however hard we strive to dodge it or put it off, death arrives for everyone in time, billions of years from now, when our sun engulfs the Earth, or if some catastrophic blow, like an asteroid strike, takes place. Our being will break down into tiny atoms strewn across the immensity of space, drifting randomly across the cosmic void. We'll go back to those same particles that first gave us life. In short, we'll slip once more into a condition of non-being till the cosmos will keep pressing onward. Suns will keep rising and falling on endless worlds. Seasons will shift and the tides will rise and fall. New stars will form and worlds will take shape. Feeding the ever-shifting tapestry of life, the universe itself will keep stretching and changing through the ages. Everything proceeds just as it did before, save for one difference this time. Your bodily self has transformed, leaving you blind to the change taking place. As a result, you might not notice the shifts unfolding around you. So, when you lift your eyes to the night sky, bear in mind that those stars overhead may consist of atoms that once formed essential parts of some living creature. Space stands for endless possibility. It is a domain where even what seems impossible can occur, and sometimes strange anomalies appear that prove tough to explain in a cosmos ruled by rigid mathematical laws. Simply glance at the night sky overhead. Why do the stars, bound by these unchanging mathematical laws, spread out in a condition of total chaos? Why don't stars echo patterns across the cosmos? Might this disordered layout be a cosmic signal, one that slipped past and escaped humanity's notice across the ages? Precisely shaped signal from some alien intelligence? And what of the endless billions of stars that pepper the boundless cosmos? How can it be that we sit amid an endless count of gleaming stars and still the heavens stay black? If the cosmos is truly endless and eternal, and the stars sit evenly spread across the immensity of space, then whichever way we turn, we ought to spot a star. Light from those stars, no matter how far, would in time arrive at our world. From the dawn of time, every curious person has pondered these very questions at least once. With progress and access to cutting-edge space instruments now in our hands, we stand nearer than ever to solving the riddles that have escaped us for ages. Now we must strip away the veils of mystery that cloud our grasp of the cosmos and shine a beam on these compelling riddles of the cosmos. Study this image carefully. Here stands Eugene Cernan, shown saluting the banner of the United States, the final Apollo crewman to place a boot upon the lunar surface. If you inspect it more carefully, you may spot something rather odd. Not one star appears anywhere in the backdrop. Indeed, each picture shot on the moon in those famed Apollo missions shows a sky empty of stars. Even though the cosmos teems with endless glittering heavenly objects, the Apollo astronauts themselves affirmed they could not make out one star in the lunar sky. This puzzle has fueled countless arguments and conspiracy claims across the years. Some even treat the missing stars as alleged evidence that the moon landing was faked, and the answer to this puzzle reaches far deeper than any conspiracy claim. Indeed, solving this cosmic riddle once more points us toward a deep cosmic truth: the Big Bang. Why does space look so dark? This question's core idea was first put forward by Johannes Kepler in 1610. Our Milky Way galaxy by itself holds somewhere between 1 and 400 billion stars, and the visible cosmos holds about 1 to 200 billion galaxies. On that basis, astronomers reasoned that because the cosmos brims with a seemingly endless count of radiant, light-giving objects in every direction, by logic, any stretch of sky you pick to examine should hold thousands, if not hundreds of thousands of stars that ought to make the night sky evenly brilliant whichever way you turn. Close study implies that the heavens should shine as brightly as the sun's own surface. That is not what we see though, and it baffled astronomers. It is a paradox that needed almost 3 centuries to settle. The paradox sprang from the steady-state theory, then the most broadly held perspective on the cosmos of that era. The steady-state theory claimed the cosmos has always been and forever will stay as it is now, and further that the cosmos stretched without end, had no origin, looked the same every way, and never expanded. Early efforts to settle this paradox rested on guessing that most stars sat simply too distant to detect, and this account was soon rejected because the steady-state theory itself held that the cosmos had lasted infinitely long, so light from even the farthest stars could arrive here and help light up the sky. Johannes Kepler offered another answer to the paradox by questioning the steady-state theory. Kepler proposed that the stars of the cosmos reached only out to a limited range, past which an observer met nothing but vacant space. Though this notion sounded reasonable, of course, that answer raised the question: how distant is the edge, and what waits past that edge? Moreover, the idea of a bounded cosmos brought problems, like it would someday cave inward under the gravitational tug of its stars and worlds. So, most astronomers kept on assuming that the cosmos had no bounds, and so the paradox and the steady-state theory sat unchanged, unsolved, and overlooked until almost 2 centuries later, when Heinrich Wilhelm Olbers, a celebrated German astronomer, revived the paradox anew and once more posed the question: why does the night stay dark? From then on, Olbers' name has stayed tightly linked with the paradox. Again, the prevailing view in his day held that the cosmos stood still, endlessly old and endless in scale. This time, Olbers offered a plain answer: if we take the cosmos as infinite, it follows that opaque objects within it would also exist without end, like dust and stone that block the glow of far-off stars, causing them to look dimmer. That cosmic dust slowly soaks up and stops starlight as it travels through the void. Even today, most people still accept this theory, drawing parallels between it and the way clouds block the sun's light and view. Cosmic rocks and dust as well could eclipse light from stars. However, Olbers' persuasive answer still does not entirely solve the problem, as any rock or dust would eventually warm up and radiate the energy absorbed. The universe would still contain the same amount of radiation. The dust merely serves as a mediator, so to speak, between the stars and the observer. Ultimately, the energy we measure on Earth would be the same. So, what's the answer to the paradox? The answer to the paradox would be revealed after a span of another 100 years. In 1990, when Edwin Hubble peered through his powerful telescope, he hoped for a cosmos that would be collapsing, as that would prove a finite cosmos, just like Kepler said. But to his shock, he discovered that the cosmos was not collapsing in on itself, but rather the galaxies were drifting away from us, as if the space between was expanding. In fact, the farther away the galaxy, the faster it was moving away. The universe appears to not be falling in on itself, not remaining still, but expanding. This raised a fresh question: if the universe is expanding, then what does that mean for the early universe? Cosmologists now believe that the cosmos was once incredibly small and dense, and that it expanded rapidly in a phenomenon known as cosmic inflation. Can be seen from Earth. When we aim our telescopes past the earliest stars, we see this light. This is not starlight, but the glow left over from the Big Bang, forming a background beyond the stars. But wait. The Big Bang theory seems to present a new problem. It claims that the universe was much brighter in the past, especially at the end of the recombination era. All points of the local sky at that era were comparable in brightness to the surface of the sun, due to the high temperature of the cosmos in that era, so the cosmic microwave background should actually be dominating our night skies back on Earth, resulting in a constant need to wear sunglasses all the time to avoid being blinded by the intense brightness of the cosmos. Thankfully, this is again offset by the fact that the cosmos is expanding, and the expansion hasn't stopped after the Big Bang. Instead, it has only gotten faster, meaning fresh space is constantly being created even faster than the speed of light itself. At first sight, this may seem a violation of the principle of special relativity, which states that nothing can move through space faster than the speed of light, but in fact, it's not. The expansion of space is not caused by objects racing through space, but rather by the stretching of space itself. This stretching comes from the effects of dark energy, mysterious force that is driving the expansion of the universe to accelerate. The expansion of space is measured by a quantity known as the Hubble constant, which expresses the pace at which the universe is expanding. Currently, the best estimates of the Hubble constant suggest that space is expanding at a pace of about 73 kilometers per second per megaparsec, which means that the distance between two spots in space will double in size in about 9 billion years. Now, as you may know, light is a wave, and as stars drift away from us, their light waves get stretched out. The human eye can only see certain wavelengths of light, and when the wavelengths grow too long, we can no longer see them. This is named redshift, as red has the longest wavelength of all the visible colors. For very distant objects, the light waves get stretched so far that they become infrared, and we can no longer see them. So, in a sense, the night sky is lit up. We just can't see it because of our limited human eyesight, but telescopes can, and that is why we get to view such images. So finally, this is how the answer to the paradox plays out. Because of the finite speed of light and the fact that the cosmos has a finite age of about 13 billion years. This finite age means we can only see stars and galaxies whose light has had enough time to reach us. The expansion of spacetime complicates things even more. In the far-out regions of space, where space is expanding faster than the speed of light, the glow from those galaxies will never outrun the expansion. No matter what we do or how long we wait, we'll never be able to view light from those galaxies. It shall never light up our skies. What we view in the night sky is just a tiny fraction of the whole cosmos. We call this the visible universe, and we cannot, even with the most powerful telescopes, peer beyond this horizon. It isn't just a boundary in space. It's a boundary in time. Beyond the rim of our visible universe, the light will never outrun the expansion. Due to this expansion, much farther into the future, about 100 billion years from now, imagine we devise a powerful new telescope which will allow us to survey space beyond the galaxy. But as we glance through the telescope, we find nothing but darkness and vacant space. The generation of people have come to realize that they exist within a seemingly endless and almost signal-starved void. As the age of the cosmos approaches 100 billion, the expansion of the cosmos will cause all other galaxies to vanish. Beyond the cosmic photon horizon, this means that light from other galaxies will no longer be able to arrive here. Put another way, galaxies will be forced aside out of the observable universe and can therefore no longer be observed. Today, we shed about 20,000 stars a second. And if you think about it, we are rather fortunate to exist at a moment in time when we have access to such an abundance of knowledge. Sure, there are a lot of things about the universe that we do not understand, but at least there's hope that someday we will. The distant future of 100 billion CE, however, would be so knowledge-deprived that when they aim their equivalent of the Hubble telescope towards a seemingly vacant region of space, the returned image would likewise be empty. Of course, the same holds true today. We have no way of knowing what lies beyond the observable universe, but one final question remains. Why are these moon photos devoid of stars? Surely, with nothing in the way like an atmosphere, we should be able to spot some stars in the background. For this, we must study how color is actually formed. Color is a complex exchange between light and matter. Light is composed of electromagnetic waves of varying wavelength, and when it interacts with an object, some wavelengths are absorbed by the object and others are reflected or transmitted. The hues that we see are a result of the wavelengths of light that are reflected back to our eyes. For instance, if an object appears red, it is because the object has absorbed all the other hues of the visible spectrum, such as blue and green, and reflects only red light back to our eyes. Likewise, if an object appears white, it is because it reflects all the hues of the visible spectrum, while an object that appears black absorbs all the hues and reflects none back to our eyes. We are able to see blue sky on Earth because particles in the air act like mirrors. The term literally means atmos, meaning vapor or atoms, and sphere, meaning globe. During the night, the sun sets, and there is no sky to hide our view of the stars. On the moon, however, there is no air layer to scatter light, but still we don't see stars. This is because the light from the sun travels in a straight path without scattering, and all the colors stay together. Looking toward the sun, we thus see a brilliant white glare. This is what occurred with the Apollo astronauts. Every lunar landing took place on the day side of the moon. Even though there was no atmosphere above them, the bounce of the sun's light from the moon's surface rendered their eyes temporarily blind. When one of the ward, the high brightness intensity glare from the sun blinded them and the camera's side of the stars, though one astronaut claimed being able to see some of the brightest stars when he stood in the shadow of the lunar module. Apollo's looking directly up with his protective visor lifted. Imagine though if astronauts ever landed on the night side of the moon and have their eyes adjusted to near total black conditions. They would get a stunning vista of the stars. If the Earth had no atmosphere, then even Earth's sky would look like the moon's. Presently, taking into account light pollution and given limits of the human eye, we can spot about 3,000 stars across the night sky, and only some 300 stars on a full moon night. That is why some scientists think it would be a smart plan to invest cash and effort erecting a huge telescope on the moon's dark side. The riddle of Olbers' paradox still stands among the most fascinating puzzles in cosmology, and its answer has given us a deeper understanding of the nature and structure of our universe. With millions upon billions of Earth-like worlds, life somewhere else in the cosmos without a doubt truly thrives. Across the immensity of space, we are not alone. Albert Einstein, based on a recent, thorough nationwide survey by Pew Research Center, 2/3 of all Americans now strongly hold that alien life truly does exist, and at least 51% feel fully sure that first reported by members of the military are likely evidence of intelligent life beyond Earth. And given the significant and pioneering advances in astrophysics, scientists today strongly believe a truly compelling high likelihood exists of uncovering extraterrestrial intelligence within the coming few decades. Seth Shostak, a renowned astronomer based at SETI, Search for Extraterrestrial Intelligence, has boldly declared that within just a couple of decades we will unequivocally uncover solid evidence verifying the existence of intelligent life beyond our world. As humankind spreads its ever-widening reach across the immensity of space, gathering proof of thousands of planets, one age-old question still haunts us. Is anybody out there? The immense expanse of the cosmos, filled with galaxies, stars, and planets, makes it plainly obvious that there remains a chance for living things to arise elsewhere. Even if we accept that the origin of life on Earth was a rare event, the enormous scale of the cosmos acts as a broad blank canvas for the diversity of life to arise. It is a setting that could hold intelligent creatures at every stage of progress, spanning from the least developed to the most advanced. Just picture yourself alone, drifting without weight through the immense stretch of space. The quiet can be deafening, and that emptiness feels crushing. At first glance, you may believe you are truly isolated, stripped of any company. Yet consider the complex ecosystems flourishing within our bodies, so often overlooked and dismissed. Countless microbes and minute organisms may be dwelling on your skin or inside your digestive system, their presence unknown to you. While these organisms may not possess our degree of intelligence, their presence stands as a poignant reminder that solitude can often prove an illusion. In the same way, the idea that we are alone in the universe may also be a fantasy hidden from us. Life across the cosmos could display a wide spectrum of intellect that we fail to notice without knowing. Intelligence is a remarkable trait that has deeply molded our own existence, and how it shows up can take varied and captivating forms across the vast expanse of the cosmos. On remote planets, creatures may have evolved astonishing and exceptional cognitive abilities, sharpened by unique environmental pressures and evolutionary roots. Some civilizations may trail behind our own, perhaps comparable to the early stages of human development. They could hold rudimentary communication skills, crude technologies, and a limited understanding of the cosmos. While on the other end, many advanced civilizations may have surpassed our level. Such beings could hold deeply advanced intellect, able to achieve extraordinary feats of knowledge, technology, and star-to-star travel. Their scientific achievements and cultural advances could outstrip our current understanding, making them seem godlike from our limited perspective. The sheer diversity of intelligence in space surpasses the boundaries of our wildest imagination. The fact is, our self-proclaimed progress might potentially look tiny when viewed on a galactic scale. In our quest to better grasp the vastness of the universe and our place within it, researchers and futurists have crafted assorted scales and measures. The such yardstick, the Kartagev scale, put forward by Russian astrophysicist Nikolai Kartagev in 1964, provides a system for sorting civilizations according to their energy consumption and technological advancements. The scale acts as a powerful tool for classifying and contemplating our future trajectory as a species. The Kartagev scale is a four-tiered system that gauges a civilization's ability to capture and utilize energy. The scale is based on the premise that a civilization level of technological progress is directly related to the quantity of energy it can command. Type I civilization, or a planetary civilization, can harness and employ every bit of energy available on its homeworld. This includes utilizing renewable energy sources such as solar, wind, and geothermal force to drive their industries and fill their energy demand. They have reached global unity and hold the power to manage all the resources of their entire planet. Type E civilization, or stellar civilization, possesses the capacity to harness the energy of their parent star. They can build colossal structures like Dyson spheres or Dyson swarms to surround their sun and collect its energy yield. Such a civilization can draw on the huge riches of their solar system and use them to power their advanced technologies and travel among the stars. Type 3 civilization, or a galactic civilization, could harness the energy wealth of an entire galaxy, relocate planets, feed black holes with stars, and even reshape the fabric of space-time. And a Type IV civilization would have the power to create a universe itself. By this scale, we still have not attained Type 1 civilization standing, but we are no longer a Type 0 civilization. Human beings rate at roughly 0.73 on the Kartagev scale. No renowned theoretical physicist has projected that if we raise energy consumption by 3% yearly, it would require 100 to 200 years to arrive at Type 1 civilization. Once we attain this status, we will be able to tap all the sunlight, wind, and tides available to us. Weather conditions would be steered by our will, and we'd be able to alter the course of quakes and volcanoes and raise floating cities in a closely parallel fashion. Just like the hierarchy used to classify power utilization, different civilizations exhibit distinct forms of communication, which can hinder their ability to understand each other. Type 1 civilizations with their full planetary energy utilization are likely to rely on traditional messaging methods such as radio waves, electromagnetic signals, and optical communication. However, as they ascend the scale, they may adopt technologies that allow for more sophisticated and efficient ways to communicate. Type 2 civilizations, for instance, could employ highly sophisticated forms of long-distance communication, such as gravitational wave communication or systems built on quantum entanglement. Type 3 civilizations able to galaxy-to-galaxy travel may use techniques past our present understanding, such as wormholes or subspace communication. Closing these rifts is vital for establishing meaningful and effective pathways of understanding. In order for different civilizations to communicate successfully, they'd have to share a common mode of communication. In our early efforts as Type 0.1 civilization, we started by launching physical messages into outer space. These messages, packaged in many forms, served as a vehicle to communicate our presence and curiosity to the vast unknown. As the first major initiatives to reach out to potential extraterrestrial life, the Pioneer plaques and Voyager golden records were attached to space probes launched past our solar system. The plaques crafted by astronomer Carl Sagan and his group, contains symbolic depictions of humanity, including a map of our location in the galaxy and a silhouette of a human figure. Similarly, the Voyager Golden Record, assembled by a committee led by Saga, featured an array of sounds, images, and music, highlighting the diversity of life and culture of Earth. The Voyager probes now sit 23 billion kilometers or 14 billion miles away from Earth, rendering them the most distant human-built object alive. But while these messages stood for our curiosity and desire for contact, they also present significant limitations in effectively forging meaningful communication. The vastness of space poses a major challenge when it comes to locating and meeting physical messages sent out into the cosmos. Plaques and records sent into space are tiny compared to the enormous distances they cover. Space is huge and mostly empty, making it highly unlikely for any extraterrestrial civilization to tumble upon our plaques or records by chance. Additionally, physical messages such as the plaques and records are merely a form of one-way communication. They act as a representation of our existence and ambitions, but they lack the ability to receive or transmit replies from potential recipients. Even if an advanced civilization were to stumble on these messages, the absence of a means for them to respond directly blocks the establishment of a meaningful dialogue. The unidirectional nature of physical messages restricts the chance for an interactive exchange of ideas, knowledge, and cultural understanding among civilization. Finally, the vast gaps between celestial bodies mean that the voyage of physical messages can last hundreds or even thousands of years. In the case of the Voyager Golden Records, for example, it would take eons for any potential answer to reach us. The timescales involved in interstellar communication again make it impractical for immediate or real-time exchanges, limiting the possibilities of timely interaction and mutual learning. After 60 years of beaming various signals and scanning the skies, trying to detect artificial signals, we still have found nothing at all, and we remain unheard. Today, the leading world body devoted to the search for extraterrestrial intelligence is a venture called SETI, an abbreviation for the Hunt for Extraterrestrial Intelligence. This project relies on the use of radio telescopes catch radio waves as we can't go to space aboard spacecraft to find that intelligent life. What we seek are radio signal. Researchers use radio telescopes placed around the globe to scan the skies for narrowband signals that clearly stand out against the backdrop of cosmic noise. It allows scientists to listen in on the murmurs of the universe. Just like tuning your FM radio to find the matching channel of a radio station, scientists often hunt for signals in the waterhole frequency range. H covers the hydrogen line and the hydroxyl line. The thinking is that these frequencies are natural picks for communication given their closeness in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxyl, which are plentiful in the universe. Still, a big hurdle blocks our way. It's the language barrier. Language acts as the bedrock of human communication, letting us express ideas, emotions, and knowledge. But when it comes to extraterrestrial beings, the very idea of language becomes difficult to grasp. How do we decipher the codes of an alien civilization? What kinds of communication would they use? These questions lie at the core of the language barrier of SETI, a challenge that their scientists and researchers wrestle with every day. When attempting to decode ancient languages, linguists heavily rely on context and comparisons with other languages to grasp their meaning. However, when faced with the task of decoding an alien language transmission, these familiar tools are missing. No context exists, and there are no related languages to draw comparisons from, and presuming aliens use a spoken language is a major assumption given that numerous animal species communicate without speech. For example, cuttlefish and chameleons communicate via body color languages, while ants and honeybees use pheromones to communicate within their kind. Even if we grasped their language's letters and words, could we really understand what they're saying? Language for us is rooted in cultures and requires a common frame of reference. If you were to say, "I'm going on a hike," and filming some stunning views with my drone to a squirrel in the park, it would have no way of grasping your statement. You would need to clarify what a hike is, what filming means, what stunning views are, what a drone is, what technology is, what flight is, what cameras are, what video recording is. A visual appreciation, all of which feel natural to modern humans. If such a scenario were to happen, it's very likely that the alien civilization is far more advanced than humans, having mastered interstellar travel and possibly even faster than light travel. Therefore, it becomes vital for us to demonstrate that we possess at least a basic understanding of the cosmos in order to establish meaningful communication with them. Mathematics, as far as we can tell, is a universal language, a language that transcends cultural and linguistic divide. By tapping the power of mathematical concepts, we might open a path of communication with alien civilization. Basic concepts such as addition, subtraction, multiplication, and division are universally valid, serving as a framework for numerical communication. Regardless of place in the universe, the fundamental truth remains that 2 plus 2 equals, and the ratio of a circle's circumference to its diameter equals approximately 345 2045 2, and so on. Though these specific numerical labels may vary across civilizations, the same method of mathematical communication with aliens is through the use of bits. In digital communication, a bit is the tiniest unit of information, represented by a binary value of 0 or. By using a string of bits, we can encode and send messages. For example, we can assign a unique series of bits to each letter of the alphabet, forming a binary code that stands for written communication. Thus, we can present the concept that 1 bit marks the letter A, 2 bits represent the letter B, and so forth. This binary code could act as a basis for communication, enabling us to transmit longer written messages that could be grasped by an intelligent alien civilization. Therefore, we could show the aliens our grasp of mathematics, though it would be a vast intellectual challenge humankind has ever faced. Composing a message that aliens can understand will be extremely difficult, and dialogue may nearly be impossible. Extraterrestrials could be millions of years more advanced than we are. These imagined life forms may have long left behind their biological bodies, exist only within a computerized body. In this scenario, they may have given up their personal consciousness to fuse into a global digital network of minds, giving rise to a vast collective consciousness. Given this huge intelligence gap and the utter ignorance about the possible aims of an extraterrestrial intelligence, this is why some scientists have voiced their doubts about announcing our existence. Extraterrestrials, even if there were potential risks involved, even if another civilization can reach Earth, it's already too late to hide our existence. Any civilization with the ability to journey between the stars can already pick up our radio and broadcasts that are spilling off into space. There's no extra risk in sending signals through active SETI. Considering the information we now hold, it is plausible that a first contact could happen in the near future. It's also possible that some civilization has already listened to our messages, but chose not to reply because they prefer it that way. All these processes discussed are called active SETI or METI, messaging extraterrestrial intelligence, which involves the deliberate sending of messages or signals from Earth into space. By taking a proactive role in starting communication, scientists hope to attract the attention of intelligent beings that may be listening or able to receive the transmitted signals. This move from passive observation to active engagement shows a growing belief that humanity should actively participate in the quest to make contact with other civilization. Nevertheless, how is it possible that given the huge possibility of other civilizations, we still haven't received any evidence of their existence? The riddle of great silence was first raised by legendary physicist Enrico Fermi and is widely known as the Fermi paradox. Chatting with his colleagues once during lunchtime, he put forward a seemingly simple question: so where is everybody? Why haven't we spotted any proof of alien civilizations yet? given how likely it is that they exist. Perhaps at the end of the day, maybe they simply refuse to communicate with us. When you weigh our civilization's level of development, the answer is pretty obvious. Why would they? The logistics required for travel between stars are only available to civilizations that have reached Type 2 at the least, and in their judgment, we're not worth it. What person of sound mind would try to communicate with ants? How would an ant be able to tell that someone's trying to communicate with it? After all, in terms of our development and technological prowess compared to them, we are akin to highly developed ants that have taken over the whole world. This is called the zoo hypothesis. The extraterrestrials may have decided not to open contact or reveal their presence for various reasons, such as respecting our development and not disrupting our evolution, avoiding potential conflicts or cultural clashes, or simply lacking any interest in communicating with less advanced civilization. Second explanation for the Fermi paradox is that we may have already received those signals, but we haven't noticed it, we haven't perceived the signals, or we haven't been able to understand or translate them. In this case, some strange signals from outer space have been received. Their origins are now being examined, and they have posed serious questions for scientists. The best-known signal that has been detected came in 1977 at Ohio State University's Big Ear radio telescope, while searching for signals from another civilization. Loud message spread out over frequency was observed. It seemed exactly like the kind of signal we would want to receive from extraterrestrial beings. While at work on the night shift on July 15, 1977, Jerry R. Heman, a professor at Ohio State University and a SETI project volunteer, observed the peculiar transcription of the section of paper feed. Later, it was confirmed that this pulse was the most intense anomalous signal caught up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times above conventional signals. It had come from Sagittarius constellation. The computer processed the received signals into run of alphanumeric characters, producing the sequence 6EQA chime. In fact, it was so astounding that when the tech looked at the printout the next morning, he wrote "Wow" in the margin, and that grew famous as the "Wow" signal, which has kept the international scientific community on edge until today. Eman and his team conducted an exhaustive examination of the signal and finally ruled out any interference coming from Earth. Over the following months, the operators of the radio telescope attempted to find the signal again, but they were unsuccessful. Astronomers have studied the same part of the sky many times since then, hoping to find the "wow" signal again, yet they have never been able to replicate it. The key to progress in IT is to catch a signal that is as remarkable as the "wow" signal, but not just once. It needs to be seen repeated. Today, the origin of that signal is still under investigation. There are hundreds of billions of suns in our galaxy alone, and there are billions of galaxies in the universe. If life forms on only a minuscule fraction of those planets, then life is prevalent throughout the cosmos. That's why human beings and their passion for knowledge and exploration have begun the search for intelligent life with the hope of sooner or later finding it or being found by it. First contact may not happen within our lifetimes, but whenever that occurs, it will prove a turning point in the life of the human species. What will happen from then on? What follows when we receive a signal and it is confirmed as extraterrestrial? How would that reshape our lives, our priorities, our conception of the world, and our own identity? Will mankind be ready? On November 13, 2004, researchers at NASA were using the Hubble Space Telescope to capture images of a once unexplored and empty region of the sky. With low and minimal expectation, they did not expect a lot back, just a dark and empty image, and the scientists could call it a day. The telescope would send back, however, an image of a planet located just 5 light-years away from us, circling a star double the size of our sun. This was the first time a planet was directly viewed through a telescope. Against their expectations, the scientists could not wrap their heads around what had just unfolded. Never before in history had a planet been found out on the basis of direct observation. In fact, the man who discovered it said he nearly had a heart attack. The frame that was captured reveals a star at the center, now formerly known as Fomalhaut. It is ringed by huge swirling clouds of dust and debris encircled by a continuous round asteroid belt, and among these millions of stones dotting the image lies a planet surrounded by a true mystery. Once named Dagon, this planet, clearly visible in the photo, never truly existed. What fills your screen right now is nothing but the phantom of a planet that never came into being. Astronomy has not yet faced anything like this before. What could this be? Glitch in the matrix? Could someone else be involved? How could a whole planet go missing? In 2004, when NASA first discovered Dagon, something seemed off right from the start. It was acting strangely, defying the odds, because according to what we knew, worlds like Dagon that measured 2 to 3 times the size of Jupiter shouldn't have been able to form around such a young star like Fomalhaut, which is just 400 million years old. Our Sun, by comparison, is about 4.6 billion years old. Additionally, since that star is surrounded by a protoplanetary disk of gas, ice, and dust, the first worlds to appear around it should be superheated and glow in the infrared. But instead, this Dagon emits ultraviolet light. Moreover, that planet was incredibly radiant, blazing with an intensity rarely observed on exoplanets. Its remarkable brightness raised plenty of questions among scientists. But for the most part, scientists just thought maybe it's owing to an expansive ring system akin to Saturn, which could enhance its reflective properties, thus intensifying its luminosity by trapping and redirecting more sunlight. And yet again, research showed that Dagon behaved in a very strange manner, though nobody knows how long it takes to make one trip around Fomalhaut. Going by the estimates, the speed of the planet just kept on increasing while it sailed on its 700-year orbit around its star. During those early years, it seemed obvious that Dagon was moving in a way that a legitimate planet should not. Its unusual movements and unexplained presence never stopped puzzling the research team. However, due to various constraints, as priorities shifted in the scientific community, the resources were redirected to other projects, and the watch on Dagon unfortunately came to a halt. Nevertheless, the Hubble telescope continued recording its images over the years. This hiatus that lasted a decade came to a stop in 2020 when NASA elected to delve back into their archives, and what they found left them stunned. The planet had mysteriously vanished into thin air way back in 2014, though in previous years, the object was consistently registered by the Hubble Space Telescope. From 2006 onward, the planet started increasing in size and becoming more dim, until it chose to finish the scientists off and just disappear, as if it had never existed, leaving everyone baffled and searching for answers. It looked like the planet didn't just vanish, but faded away. Scientists had reached an impasse. All of these events went against everything the experts knew about exoplanets until now. The researchers had to practically review the data again to draw a new radical conclusion that the planet Dagon never existed, and to substitute some different object instead of Dagon. One compelling theory that surfaced about the vanishing of planet Dagon held the idea that it was a rogue world that drifted freely through the cosmos instead of a lasting member of its star system. This theory proposes that Dagon was not a lasting resident of its star system, but somehow got torn loose from its parent star, drifting into the Fomalhaut system, fascinating astronomers who clocked its presence in the nick of time and eventually exited the Fomalhaut system. The idea of a planet on the move unbound from a star's gravitational grip added a layer of wonder to the mystery. What cosmic forces shaped Dagon on its trajectory? Did it also encounter other star systems along its way, joining in gravitational dances that altered its path? As scientists dug deeper into the complex dynamics of the Fomalhaut star system, a more credible explanation surfaced. thorough analysis of the system's gravitational interactions and the presence of a massive debris disk made plain that the likelihood of Dagon being an elusive wanderer was slim. The complex gravitational forces driven by the stars and the constraints enforced by the surrounding debris disk would have heavily hindered the planet's ability to roam freely without being affected or noticed. And if planet Dagon had truly been a rogue planet crossing the system, it would have left visible traces of its passage in the surrounding debris disk, much like the streaks left by the wings of an airplane on clouds. Just as these trails offer evidence of the airplane's presence and motion, astronomers expected to observe distinctive disturbances or patterns inside the debris disk caused by the encounter with Dagon. Yet despite meticulous scrutiny, no significant indications of such disturbances have been found. The absence of discernible breadcrumbs akin to the wicks carved by airplane wings in clouds raises questions about the hypothesis of Dagon as a wandering planet. Scientific scrutiny, steered by evidence-based reasoning, forced scientists to explore other explanations for the disappearance of planet Dagon. Fresh and the most likely theory offered by the scientists suggests that the object, originally taken as an exoplanet, was a slowly dissipating dust cloud that formed as a product of a huge collision between two asteroids or planetesimals, each about 200 kilometers or 146 miles across. This discovery is even more stunning because a collision between two small celestial bodies is incredibly scarce. The ability of scientists to catch the image of the collision was an astonishing stroke of luck in the vastness of space, where distances are unimaginably immense. Such crashes between celestial objects are estimated to occur once every 2,000 years or so. The collision must have taken place in 2004, when the Hubble telescope was scanning the region around Fomalhaut. Coincidence number 1. As time went by, the dust began to spread, which explains the growth of the object's size and the fading brightness. Coincidence number 2. And the dust cloud that formed in the crash explained the eccentric orbit. Coincidence number 3. And so a chain of incredible coincidences baffled the astronomers and forged a beautiful legend of a strange and unpredictable planet, Dagon, that does not look like a planet or move like a planet, does not circle around a host star on an elliptical orbit like a planet, and instead drifts along a runaway trajectory that eventually takes it far away from the star. It was an extraordinary moment that they were able to witness and document this event, defying astronomical odds. After linking all the dots and reviewing the accumulated evidence, scientists finally concluded that Dagon, once regarded as an exoplanet, should no longer hold that status. Currently, it's believed that planet Dagon's dust cloud, stemming from a colossal collision, must cover an impressive span of 300 million kilometers. It must be made of tiny dust particles measuring just 1 micrometer across, exceeding the scale of any known planet. This massive yet tiny dust particle cloud has made Dagon invisible to the Hubble telescope. The disappearance of planet Dagon offers a rare opportunity to study planetary collisions, unlocking their dynamics and aftermath. Computer simulations and observations have revealed that powerful space crashes can even turn celestial objects into expansive clouds of fine particles. The parallels between the Dagon collision and our solar system's early stages are also notable. By studying the debris and its composition, scientists gain insights into the processes that built our cosmic neighborhood billions of years ago. The scattered particles in the Fomalhaut star system give valuable information about the building blocks of planets and the conditions that enabled their formation. This knowledge enhances our understanding of planetary systems and powers our exploration for extraterrestrial worlds. But this isn't the first time an object in space vanished before scientists' eyes. Similar tale happened with exoplanet Alpha Centauri b. In 2012, astronomers at the European Southern Observatory spotted fluctuations in the radial velocity of a star using the precise HARP spectrograph. These fluctuations could only be caused by a planet's gravitational tug. This breakthrough method known as Doppler spectroscopy, is highly trustworthy with only a 0.1 margin of error. With just one miss among 1,000 hits, it sparked a profound sensation within the scientific community. This fervor was further heightened by the fact that Alpha Centauri b sat a mere 4.1 light-years away from our solar system, stood as the closest exoplanet in proximity. Astronomers disclosed that this world circled its star too closely, outside the habitable zone, with surface temperatures reaching near 2,300 degrees Celsius, almost 3 times hotter than Venus. Scholars eagerly tried to calculate its orbit parameters. But before they could do so, Alpha Centauri b disappeared into thin air 3 years after its 2015 discovery. Reconsidering the data, experts at the University of Oxford discovered that the velocity fluctuation, first taken as proof of the exoplanet's existence, were, in fact, just calculation errors. However, it's downright strange when, instead of a planet, a star mysteriously vanishes after being carefully studied for a solid 10 years. From 2001 to 2011, numerous astronomical teams fixed their eyes on a luminous blue variable star nestled within a dwarf galaxy called PAL 26 to the Fendifu b, located 7.5 million light-years away. Their goal: to learn more about how these kinds of stars end their lives. These luminous blue variables have a unique and unmistakable light signature. They're colossal, supergiant, or hypergiant stars teetering on the edge of their life cycles. Packed with brightness and plagued by instability, they undergo violent outbursts and eruptions that cause sharp fluctuations in both their radiance and spectral characteristic. During these dramatic episodes, their luminosity may even double in intensity. Living up to the nature of these luminous blue variables, our mystery star, unsurprisingly in its advanced life stages, shone brightly with its radiant luminosity. However, when scientists pointed the powerful Very Large Telescope of the European Southern Observatory toward the PAL 293b galaxy in 2019, the star had mysteriously disappeared. Meticulous review of data collected between 2011 and 2016 revealed an unsettling truth. It had stopped being visible after 2011. According to astronomers, only 2 primary possibilities could arise from this point. Firstly, it's plausible that the star dimmed and became hidden within a shroud of ejected material, resembling the ambiguous dust cloud that may have hidden our very own Milky Way's red giant star. Betelgeuse, a couple of years ago. Under this scenario, the star might have kept up its eruptions hidden behind this thick fog of gas and dust, making it invisible to our eyes. Infrared observations conducted in 2009 hinted that this obscuring cloud would need to be bitterly cold to remain undetected and enshroud the star completely. Alternatively, based on certain models, it is suggested that the luminous blue variable star, instead of undergoing the expected supernova phase, skipped this explosive spectacle altogether and settled into a slow-turning black hole. This idea drew backing from recent research on a massive red star that quickly brightened before suddenly vanishing in a galaxy located 23 million light-years away. The researchers proposed that this star had experienced a failed supernova before its ultimate collapse. Drawing on these findings, the group postulates that the luminous blue variable star in PAL 293b was likewise in an eruptive state between 2001 and 2011, after which it vanished either by skipping the supernova stage entirely or stumbling in its attempt to initiate one. In most cases, stars approaching their end typically finish in a spectacular supernova before changing into either a black hole or a neutron star. This explosive phase is hard to miss, often lasting for several years. Astronomers would have undoubtedly caught a glimpse of such an explosion if it had taken place. This baffling situation challenges our understanding of stellar life and death, pushing us to reconsider our existing models. With the presently available information, the puzzle of the missing star presently remains unsolved, leaving astronomers eager for future readings across various wavelengths to uncover the secrets veiled within this cosmic riddle. In 1974, a remarkable spacecraft named Pioneer 16 set out on an exciting mission to survey the vastness of the asteroid belt and the huge gas giants that dominate our solar system in the outer reaches, racing at a speed of 3,000 miles per hour, or 5.1 promotional 1,000 kilometers per hour. Pioneer 16 streaked away from Earth on a transformative journey that would eventually clear the way for future endeavors, such as the Voyager probes. While the Pioneer mission ultimately scored remarkable success, it was not free of its fair share of challenges and obstacles. Little did the world know, the probe had brought with it a buried problem, a riddle that would baffle even the sharpest minds and astrophysicists. For decades, beset with a number of malfunctions, Pioneer 16 has sometimes been regarded as the luckiest spacecraft ever launched. Sometimes, a few moments in our lives dare to challenge our basic and fundamental theories. In the early 1960s, while the probe was still linked, scientists had spotted something rather striking. The probe was both easing down and drifting off course, as if an unseen force in space was hitting the brakes on and pulling it back toward the sun. Despite carrying out extensive research and doggedly analyzing data for about 15 years, the solution to this puzzle remained out of reach. Instead, the slowdown came to a sudden end, leaving behind one of the greatest mysteries in the history of spaceflight. Even today, the flyby anomaly continues to unsettle our understanding of spaceflight, making some spacecraft deviate ever so slightly from their intended trajectories. It stays a glitch that strains our knowledge and keeps us searching for answers. Sent up back in 1977 India, Pioneer 16 became NASA's trailblazing mission to the outer planets. The probe took its moniker from the bold pioneers who settled the western United States, since just like those explorers of old, Pioneer 16 aimed to boldly go where no spacecraft had gone before. Pioneer 16 spacecraft scored remarkable triumphs, marking several firsts in our space exploration. It was the first to venture past Mars, cross the asteroid belt, and reach the mighty gas giant Jupiter. Pioneer 16 also made history as the first spacecraft to employ an all-nuclear power supply and follow a trajectory that would take it beyond the edges of our solar system. Originally planned for a modest 21-month mission, Pioneer 16 far exceeded expectation, defying the odds and lasting for over 30 years. However, in January 2003, after its long and distant trek, the venerable probe spoke its final farewell, sending its last signal back to Earth. Today, Pioneer 16 keeps up its cosmic voyage, solitary craft drifting like a ghost ship through the frigid expanse of space, over 11 billion miles away in the reverse direction of the sun's motion through the galaxy. Just like its twin, Pioneer 11 launched into the great unknown a year later in 1973. Tracing in the footsteps of its predecessor, it became the second probe to successfully pass Mars, chart along the main asteroid belt, and reach the majestic planet Jupiter. Finally, Pioneer 11 carved its name in history by becoming the first spacecraft to fly by Saturn. Unlike its twin, though, after leaving Saturn, Pioneer 11 headed out of the solar system in the reverse direction at an angle of 90 degrees to pioneer its destination, the heart of the galaxy. Found within the constellation of Sagittarius in 1995, NASA received the last signal from Pioneer 11, marking the end of its communication. It quietly vanished into the depths of space, leaving behind a heritage of exploration but unknown to many. Both of them had left behind a puzzle that would baffle even the most seasoned physicists for decades. Just like many baffling puzzles, this one started with a subtle hint of inconsistency. Shortly after Pioneer 16 and 11 pushed beyond the orbits of Jupiter and Saturn, both spacecraft appeared to be showing a greater slowdown than what the navigators had initially expected. It was as if an unseen force was softly tugging them backward, closer to the Sun. While the researchers were aware that the probes would naturally decelerate to some extent due to the Sun's gravitational pull, the data showed an excessive slowdown that defied explanation. The deceleration felt by the spacecraft was incredibly tiny, just merely a billionth of Earth's gravitational acceleration. In 1998, John Anderson at JPL and his colleague figured that the spacecraft had a deceleration rate of about 300 inches per day. While this may look like a very small difference in measured acceleration compared to the predicted figures, it had significant implications. The pioneers ended up staying thousands of kilometers nearer to Earth each year than originally intended. They fell short of their expected location by a distance roughly equivalent to the gap between the Earth and the Moon. Year after year, the spacecraft found themselves drifting by a few thousand kilometers from their expected position. At first, it hadn't raised many concerns, but now it was a different story altogether. And the baffling part was that this tiny deceleration persisted as the spacecraft journeyed deeper into space. There were also two other spacecraft that encountered trajectory problems. One was Galileo, launched in 1990 to study Jupiter and its moons. The other was Both of these missions met trajectory anomalies that left scientists scratching their heads. Scientists thoroughly explored various possibilities to explain these decelerations. They weighed everything from gas leaks to the expansion of the universe. However, despite their efforts, no definitive answer was found. Due to the lack of explanation for the slowdowns, the team proposed that it could be attributed to some new physics that clashed with Einstein's general theory of relativity. This even raised the tempting possibility of undiscovered phenomena that could reshape our understanding of the cosmos. In 2004, Slava Turaev, a physicist at NASA Jet Propulsion Laboratory, had an idea brewing in his mind. He considered building a brand new probe to investigate the Pioneer anomaly to get to the bottom of it. This new craft, however, unfortunately, never left the page beyond the confines of the drawing board. Slava had to work with the data that was available, and he didn't have any new data to work with since the two spacecraft had ceased communicating with Earth. But that didn't deter Slava, though he met a couple of more challenges along the way. Firstly, those Pioneer spacecraft were built back in the day when computer-aided design wasn't in the picture. It was all plain old-fashioned paper and pencil, so he had to begin from scratch and create 3D models himself. Also, NASA never required keeping mission records, making it quite a chore to locate the data. Even with these setbacks, Slava and his team dug through old Pioneer communications and data, recovering digitized files from JPL navigators and chasing additional information from various assay centers. They uncovered boxes of magnetic tapes at NASA's Jet Propulsion Laboratory and magneto-optical tapes at NASA's AMS Research Center. Coder named Victor Tolth from Canada teamed up with Slava and helped build a program to parse and organize the data. Ultimately, Slava and his team gathered more than 43 gigabytes of information. That hardly seems like much by modern standards, but back in the 1970s, it was an astonishing stash of data. So what did he uncover? The answer to the anomaly lived in the structure of the probe itself. You see, NASA engineers had to spin the Pioneer probes to keep them stable and make sure they remained aimed toward Earth. This was essential because the antenna needed to be directed toward Earth to exchange data. By contrast, the Voyager missions possessed a more advanced technology that used thrusters to maintain spacecraft stability. However, what was driving the acceleration? Researchers found that the deceleration came from thermal radiation emitted by the spacecraft. There were two sources of thermal radiation sitting on the forward face of the spacecraft. The first source was the electric box, and the second was the radioactive fuel, responsible for generating power. Both of these sources radiated heat in the direction of the spacecraft's travel through space. That release of heat produced a slight photon push in the opposite direction of the spacecraft's motion, producing the observed deceleration. It's the same principle that operates in a solar sail, where the spacecraft is driven onward as photons from the sun strike against it. Now, Here's the curious part. The slowdown of the Pioneer probes came to a sudden stop when the radioactive material was completely spent. With the wealth of new data at their disposal, Slava and his colleagues managed to calculate the amount of heat generated by the electrical subsystems and plutonium decay in the Pioneer power sources. These calculations perfectly matched the anomalous acceleration seen on both Pioneer but other spacecraft like Galileo and Rosetta factored in the thermal recoil. Yet they still encountered deviations in their paths. When the Galileo spacecraft was heading out to Jupiter, something peculiar happened during a gravity assist pass where it swung by Earth. Scientists spotted an unforeseen rise in the craft's velocity. There was a mismatch, a difference in speed relative to Earth, with an unexpected boost of about 4 mm per second. This effect, known as the flyby anomaly, has impacted almost every spacecraft out there. The flyby anomaly reveals something quite striking. Some craft actually picked up more speed when heading toward or away from Earth than what scientists initially forecast, and so far no convincing explanation has been found. The flyby anomaly made another appearance during the near-Shoemaker incident in '98. This mission had its sights set on studying the asteroid 433, Eris. To reach its target, the near-Shoemaker spacecraft carried out a flyby of Earth. And guess what? Scientists observed an even larger deviation in the craft's velocity compared to the Galileo flight. This time, the speed jumped unexpectedly by about 13 mm per second. The repeated pattern of this phenomenon in these two cases sparked the interest of the scientific community. They began digging deeper, checking data from other flybys. As they sifted through the records, more cases turned up. The Messenger craft's flyby of Earth in 2005 and the Rosetta spacecraft flybys in 2005 and 2007 all revealed similar anomalies in their velocities. This was no longer merely a one-off incident or a measurement error. The flyby anomaly had collected enough evidence to demand serious attention. Many theories have been offered up to explain the flyby anomaly, spanning from the mundane to the extraordinary. New hypothesis centers on the shape and composition of our planet. You see, the Earth isn't a perfect sphere. It's closer to a spheroid from its rapid spin. It has uneven densities and features like mountains, oceans, and ice sheets. As spacecraft fly past Earth, they may meet different gravitational forces depending on the particular features they pass. The trouble with this theory is that there are countless spacecraft orbiting Earth all the time. And if this explanation were right, we would expect them all to feel the flyby anomaly, so there must be more to the puzzle. Another proposal suggests that the arrangement of the Moon or other planets in the solar system during a flyby, along with the positions of the oceans and tidal conditions, could be contributing factors. Even though Earth's atmosphere is thin at the altitude of flybys, it's possible that even the tiny number of atmospheric particles encountered could affect the spacecraft's trajectory. Some researchers think that the Sun could take a role in the anomaly. It's possible that the spacecraft experiences changing levels of solar winds during each flyby. Some scientists argue that relativistic effects may be involved. The spinning of the Earth, for example, might warp the fabric of the surrounding spacetime, ultimately altering the craft's trajectory. As you can see, the flyby anomaly is a complex puzzle, and the search for an explanation goes on. Scientists are carefully exploring these different theories, running experiments and studying data to unlock the secrets behind this striking phenomenon. To delve into the predictions of Einstein's theory of relativity, scientists are proposing to launch an exciting new spacecraft named STEP, which stands for Satellite Test of the Equivalence Principle. This mission was chosen by the European Space Agency back in 2012. And if it gets final approval, it will head into space by 2024. STEP's sole purpose would be to study gravity, aiming for the most sensitive measurements of gravity ever made. This remarkable craft would circle the Earth, fitted with an incredibly precise clock on board. Shielded from radiation in a vast expanse of the cosmos, it would have the freedom to observe and analyze gravity. With its exceptional sensitivity, it could sense both the gravitational forces exerted by the Earth and the Sun to an astonishing accuracy of 10⁻⁷ power. The spacecraft would follow an orbit that carries it through the various distances at which anomalies showed up during flybys. If gravity is truly the cause of these anomalies, STEP should be able to precisely show how the magnitude of the effect changes with distance from Earth. Thus, while STEP's primary focus is on deepening our understanding of gravity, it also has the chance to finally unlock the secrets of the flyby anomaly. Across human history, we've amassed an incredible body of knowledge about the cosmos around us. However, we're only at the start of this journey. The universe, a twilight realm of cryptic secrets, remains replete with unexplained mysteries and paradoxes. Shaped by hidden forces, it's like a huge jigsaw puzzle built from an endless number of pieces. But we glimpse only a small part of it, and can only guess the rest in the vastness of the cosmos. Still more countless mysteries await our curious minds. There are still many secrets yet undiscovered, enticing us to unravel the mysteries of the universe.